Hello, my name is Tanja Munz. I'm from the University of Stuttgart and I'm presenting our work Visual Interactive Neuro-Machine Translation. Neuro-machine translation is currently the most commonly used method for machine translation. It is computationally efficient, translation results can be impressive but might also contain errors. A common problem is over and under translation, when words are translated repeatedly or not at all. Additionally, the translation of documents from specific domains might be challenging. When the translation model was trained on general data, there might be words that are not known by the model or that have different meanings in different domains. Here, more background knowledge about the text is required to translate a document appropriately. Also, a translation might be correctly translated but not express someone's style or be appropriate for some occasion. Humans are slow but can detect and correct mistranslations. In a visual analytics system, both capabilities can be combined to generate high-quality translations. In our approach, a document is first translated with a neuro-machine translation model. We implemented an LSTM-based and a transformer architecture for this. Then it uses the tagged sentences for correction using filtering options. Next, sentences are visualized and can be interactively modified. After correcting sentences, user corrections are used to fine-tune the model, retranslate sentences, and improve translation quality of the document. After uploading a document, this is the overview that is provided to a user after automatic translation. On the bottom, the document view shows all sentences and their initial translations. Correct sentences can be marked as correct or mistranslated sentences marked for further investigation. To detect mistranslations, sentences can be sorted and filtered. For this, we can use the metrics view on the top that shows some metrics that correlate with translation quality in a parallel coordinates plot. It is, for example, possible to filter for sentences that have a low translation confidence. Here is, for example, a sentence visible that was undertranslated and needs correction. Additionally, the key phrase view on the top right provides a list of words that can be used for sentence filtering. Key phrases are words that are domain-specific and were not often included in the vocabulary of the training data. Here, an example where each occurrence of a key phrase was mistranslated. After selecting a sentence, this is the more detailed view to explore, understand, and correct translations. The attention view visualizes the relationship between words of the source sentences and the current translation. The thickness of the connecting lines and the transparency of words correlates with the importance of source words for the translated words. This usually shows an alignment between translated words in different languages. It can be used, for example, to detect areas that are not well translated. This view supports interaction to analyze the influence of individual words. The beam search view on the bottom visualizes different translation possibilities as hierarchical structure and provides insights how the underlying translation model chooses the final translation. This is an interactive visualization that can be used for post-editing the machine-generated translations. Here, for example, we choose a different translation from the recommendations. This is an example where we select a different recommended word. Furthermore, users can type in words that are not recommended or included in the vocabulary of the model to improve the translation. After correcting sentences, our model can be retrained using the user corrections and the document can get retranslated. In the example from before, the key phrase is now correctly translated after retraining for only a few sentences containing the term. This is visible from the changes that are marked in the document view. We provide a source code of our approach and pre-trained models online. Feel free to try our approach yourself.